Hello, everyone, and welcome to SIG Scheduling Weekly Meeting. Today is our 5 p.m. PT Pacific Time version of our meeting. I don't have a whole lot of items for today's meeting, so hopefully we can cut it short a little bit. But if you have other items, you're more than welcome to talk about those. So the items that I have on the agenda is one, a follow-up on image locality from Harry. Harry, what's the update on that?
Hey, can you hear me?
Yes.
Yeah. So I already post a test result in the doc, and according to my experiments, so if we give this priority a weight like 3 or 4 out of 10, then the distribution will be reasonable to me. And you can see in that test, there will be like 48 pods being scheduled to the nodes with this image exists, while the expected pods number will be 30. So I think this should be a reasonable number. And even in the worst case, if the image is very large, then the priority score is a maximum. Then the hot nodes will only have 70 or more pods being scheduled. So it's still not very bad.
So help me understand that spreadsheet a bit. So just in the spreadsheet, you say a hot node, and then there is a number. Is that the number of pods on hottest nodes?
Yeah, pods being scheduled on that node.
Okay. All right. So I see sometimes that it's over 100, but it may not be bad given the number of pods. One question for you is that.
Mm-hmm.
Oh, sorry if I interrupted you. You go ahead and explain, and I'll ask questions later.
Okay, so that is the first experiment I did, and the second experiment I did is we can actually give a discount when calculating the score. The discount is calculated by considering the distribution of the given image. So basically, the final score will be the real score and multiply this discount. And if we use this option, the test result will be more stable because even this priority has a default weight, then the final score will be calculated to consider the distribution of the image. And you can see, no matter in any cases, the distribution of the pods will not be accumulated in certain nodes because the distribution of the image has been put into consideration.
So, okay, so let's see. So you said what is that option 2? So it's nodes with image divided.
That is if this image has been existed in, for example, certain nodes, then I say if there's more nodes has this image, then we can give it relatively higher score during calculating, because it means its distribution is more balanced. So it's how I calculated this score. It's just another approach.
I see. Yeah, it actually might make sense. I have to think about it, but yeah.
Yeah, we can think about it later. I just did an experiment like that.
Right, but thank you for doing the experiment. And then one question for you is that have you enabled this priority function among all other priority functions that are already enabled by default in the scheduler?
Yes, yeah. All the priority has been enabled, but they will have same score.
Right.
Yeah.
By same score, so, same weight, right?
Yeah, in weight. And so in a real world user case, I will expect the distribution more balanced, because the combination of different priorities will have different impact.
Right. Yeah. Okay. Thank you for the update. So this result seems promising. We can, especially like the second approach. I don't know.
Yeah, we can decide it later.
Yeah.
Yeah, about the implementation part.
So it would be helpful if you just update those PRs or the issue with your.
Yes. Yeah, definitely.
Yeah, we can discuss with the other parties. I guess Red Hat folks like Ravi and Avesh, I'm not so sure if Avesh is here today. But if you guys have any comments or questions about this, since I know that some of you guys had some questions about the usefulness of this feature, please ask Harry now or later. Okay.
Probably once he updates the issue with the experimental setup, like how he has done, I will look into it.
Okay, sounds good. Thank you. One more item is that basically I have sent out the first draft of the scheduling framework. It's about the architectural changes that I thought would be useful to make the scheduler more extensible by enabling the scheduler to have a larger range of plugins, basically. And also, there are some small differences other than just the plugins. There is this new kind of reservation and admission state in the scheduler that helps us enable some more advanced features, such as maybe gang scheduling and dynamic binding of resources and all of that. So if you're interested, please take a look. I have already sent an email to the SIG scheduling mailing list with the link. And I also mentioned in that same email that in order to access the document, you need to be on the Kubernetes-dev mailing list, which is one of our Google groups. If you're not, you won't be able to access the document. I already received a bunch of other requests to give access to the document. I cannot grant individual access to the document. Make sure that you are on the mailing list. So these are all the things that I actually wanted to talk about. Since Klaus is here, Klaus, do you have any updates for us from like the kube arbitrator or gang scheduling or anything that you are working on?
Oh yes, for the gang scheduling, I think we are going to try to define the interface by the CRD firstly, because we already have lots of discussion about the gang scheduling, some requirement, and we got lots of requirement about gang scheduling, such as maybe some related feature here, and I think we are going to as you know, Kube arbitrator already have the support to the gang scheduling. I think I will give maybe a first version for the gang scheduling based on the current API definition. And the definition is not finalized. We will continue to update that API definition. And another point is as we think of offline, the Kube arbitrator will also leverage a scheduling framework to support batch batch workload. I think this makes sense to share the same framework to avoid the code duplicate. But I think some concept or maybe some term maybe batch specific. For example, queue or something others. That will be included in the Kube arbitrator, but the common part will be the scaling framework. So I think this will be our direction for this one. And I already have a draft first implementation about our API part. I already opened an issue in the Kube arbitrator. If anyone have interesting or have any comments to this part, please go ahead to give comments. Yes, and if there are any more requirement about batch workload, please open an issue in Kube arbitrator. I think we will continue to support batch workload in this project. Yeah.
Sounds good. Yeah, I totally agree with you. If it is possible, it would be great to basically share a lot of the skeleton or the basics of the scheduling between the two. We can basically have two separate scheduler. One is for batch and the other one for other non-batch workloads. That is fine. But if the two schedulers can share the same framework, it'll be great. So if we can make the necessary changes to the current proposal and make it possible to use it for building the batch scheduler as well, it'll be great because it will reduce the amount of maintenance that we are going to have in the future.
Yes.
So please take a look. I actually replied to one of your comments on the document.
Yeah.
Please take another look and let me know if what I said makes sense, and also give me any suggestions to
Sure.
change this design.
Yes.
To make it possible.
Sure. Yes, I think we need to share the same scheduling framework, because we don't want to, if someone interested in the two part, that will be really hard to learn total different framework. This doesn't good for the community. I think we need to share the same thing. And for the different workload type, there may be some customized or some special concept or term in different scheduling, but the overall scheduling or the overall logic should be same.
Yeah,
yes,
I agree.
Yes,
I agree. So that should be our direction, in my opinion. We should try very hard to basically change this design, or maybe the design already supports it. I cannot really tell, because I don't have the full context about the requirements of gang scheduling, but I feel like it might be already there, or might be close to what we want it to be. So it'll be great to use that framework for both. One more question that I have from you is that so you are building Cube Arbitrator as an incubator project, right?
Yes. Yeah.
It's in a separate repo. So do you, other than yourself and I guess some of your colleagues over there, do you have other contributors from other companies?
There are also some. We also have some customer would like to run such to ask Kubernetes to support a batch system. Yes, this is the customer part. Another part from our team, we have other resource. Zhe give lots of contribute to the Kube Arbitrator, and I think in the we will have more resource for this part to do the contribution for the Kube Arbitrator. I think definitely for the batch system to the Kubernetes, we our product RSF Eagle, we have several experience about batch system for this part. Yeah. And for the other contribution, I think we have some user. We do have some contributor. One is from Too Simple, another startup company from China. They would like to run MXNet on the Kube Arbitrator to support GPU topologic for this part. I think this will be next step for this part. And I think there also there are also a TNTT, maybe TNTT. I can't remember the name of that part. They also give some contribute to this to the Kube Arbitrator for this part. And a startup SIG Cloud from China. I think this should be SIG Cloud. They do the integration from the Kubeflow. The TF operator do the integration with the Kube Arbitrator to use it to support GAN scheduling. Yeah, so we have a previous version. I think this is the user from RAS, and yes, and because the API maybe changed, I think we need to have some update to the TF operator to make the API align, so we can.
So what is the API today? Is it still using PDB?
Yes, the previous version I using PDB to define the minimal variable. And in the new for the new API, I think we may introduce another CRD to replace PDB because the PDB using for the other purpose in the Kubernetes. I think I will replace this one. Yes, I think that is an important change about the API part. Yeah. And for our customer, I think maybe I can't give the name of.
No. I was asking only for the contributors. I don't want you to reveal any confidential information.
Yeah.
I just wanted to hear about the contributors, because I was wondering if we have like clear instructions about how people can start contributing if they are interested in the Cube Arbitrator.
Yeah, sure. I think for the contribution, I think yes. I think for this part, I'm going to give more introduction, and if there anyone want to introduce, that's why I would like to give guidance or give help to contribute to help to contribute that project.
Sure, sounds great. Okay. These are all that I wanted to say. I just, since Ravi is here, I've already pinged Ravi to update the resource code documentation because we need that new information about how to limit users at certain priorities, priorities for 111, and we need to link that to our release notes for 111. Ravi, please work with us to update these documents.
Yeah, because is working on it. So hopefully by today, late in the evening, India time, we should see an update.
All right, great, thank you.
So I have some feedback on the Cube arbitrator plus the new scheduling framework. So most of the high performance workloads are actually, I mean, some of the customers are interested in using that in OpenShift. And instead of having like two different frameworks or two different schedulers as we were thinking earlier, if we could combine that into a single thing, it would be helpful for us too, and we could get started on contributing as well. Because we have some customers who are interested in using it, but as of now, since nothing is in beta, which would be tech preview in OpenShift, we are not encouraging the customers at this point of time. So if we have a single framework or a scheduler that could do both, it would be really helpful.
Yeah, so for the as far as framework is concerned, I guess it will take at least a couple of release cycles before we can see a working version of the scheduling framework. So depending on your timelines and your requirements, it may or may not be ready for your customers in time. But in terms of combining the two schedulers, yes, that will certainly be beneficial to customers and also us as developers, because it's going to make things easier for us if we can have just one scheduler as opposed to two. Whether we can really pull it off without making scheduler too complex or not is the question that we need to answer. If we can actually find a solution for that, I agree that it would be great.
Yeah, so it's not the timeline at this point of time. If we can come up with some design, that would be helpful too.
Sure. Please also look at that scheduling framework design document. I know maybe it's a little long, although I tried to basically make it short as much as possible. It's like 10 pages now, but I couldn't really make it much shorter than this. I tried to basically skip all the implementation details in that document to focus on the architecture. If you don't want to go through all the details, I still encourage you to go and read some of the design main design areas towards like how the reservation and admission of pod works, and maybe look at the use cases. Maybe that actually may not be a bad idea. Look at the use cases part of the design doc, and then you will see some information and try to look those up in the document if you don't have the time to go through the whole document. This is not only for you, Ravi. I'm just talking about other people who might be interested in looking at a document, but they don't have the time to read the whole thing.
Sure, I will. Thank you.
Sure, thank you. Is there anything else? No question, no comments. So if there is nothing else, we can finish this meeting today, and I will see some of you guys next week. Thank you, everyone. Bye.
Okay, bye.